And quantum field theory tells us that all fundamental particles are waves in their own fields. This may give us a more physical medium that drives these waves of possibility. And if you thought the Copenhagen interpretation was freaky, wait till we get to the many worlds interpretation, which we will, right here on Spacetime. Thanks to the Great Courses Plus for sponsoring this episode. The Great Courses Plus is a service that allows you to learn about a range of topics from educators, including Ivy League professors and other teachers from around the world. Go to thegreatcoursesplus.com/spacetime and get access to a library of different video lectures about science, math, history, literature, or even how to cook, play chess, or become a photographer. New subjects, lectures, and professors are added every month. I've recently been exploring the Great Courses Plus quantum mechanics content. It's a thorough overview of a very complicated subject matter. With the Great Courses Plus, you can watch as many different lectures as you want, anytime, anywhere, without tests or exams. Help support the show and start your 1-month trial by going to thegreatcoursesplus.com/spacetime. Okay, let's look at some of the comments from our episode on the role of Jupiter in the formation of our solar system. Jason Blank asks, wasn't Jupiter almost a star? Well, the lowest mass stars are around 7.5% the mass of the Sun, while Jupiter is 1/10,000th of a solar mass. So it's not really all that close. You'd need around 75 Jupiters piled on top of each other to ignite sustained fusion in its core. A few of you wonder why we think Jupiter even needs to have a rocky core. Well, the Sun and other stars don't need rocky cores because they are massive enough for all of that gas to collapse by itself. There's a minimum mass that's capable of doing that. It's called the Jeans mass. It depends on cloud size, temperature, rotation rate, and composition. For typical interstellar clouds, the Jeans mass is quite a bit smaller than the Sun's mass, but still much, much larger than Jupiter's. For Jupiter to form its giant ball of gas, it needed a rocky core to start the process. That core may have dissolved since Jupiter first formed. Juno will figure that out by carefully mapping Jupiter's gravitational and magnetic fields. Bike Jake would like me to talk more about resonant frequencies. My pleasure. A resonant frequency is when two orbiting bodies have orbital periods that form a neat ratio of small integers. For example, for every one orbit of Jupiter's moon Io, its moon Europa orbits twice, and Ganymede 4 times. For every 8 Earth orbits, Venus does 13. These integer ratios maximize the amount of time that the planets spend in closest proximity. When these bodies are closest together, they have the strongest gravitational pull on each other, and that pull stops them from straying out of that resonant frequency. An imposter complains that the Jupiter episode was way too understandable. Don't worry, we got some incomprehensible content coming your way real soon.